So today I'm going to be looking at questions 16 through 21. So I'm going to be looking at this whole page. 16 and 17, I'm going to be looking at constructions. Now, I'm not going to add this on the homework, 16 and 17, but I do want you to know how to do these because they can be given on a test. So 16 and 17, the first one is construct a inscribe, a square inscribed in the given circle. Okay. So basically, I'm going to construct a square. I'm going to draw a square. Now we know for squares, the corners are 90 degrees. All the sides are equal. That's one thing we know. Inscribed, what inscribed means is that the corners are on the circle. So I kind of expect roughly, I'm going to say, what do I expect? I expect four corners on the circle and then I can connect them. That's really what I'm expecting, but I'm not going to freestyle them. I'm not going to do that. So but just giving us idea what we expect. For number 17, construct a regular hexagon. Now, hexagon means 6 sides. And regular means all the sides are the same length. All the angles inside are also going to be the same length. Now, construct a regular hexagon inscribed in the given circle. Okay, I'm going to do that. But for us to do this, I'm going to use a tool that we use at the beginning of the school year. I'm going to use this. Okay. So here, construct a squared inscribed in the given circle. Okay, now let's take a look how we're going to do this. What I need to do, first of all, let me draw a diameter. So I'm going to grab my ruler. It goes through the center of the circle. I'm going to use this marker. Let's change this to red. So just a diameter, any diameter, anywhere. So I'm going to grab my marker here. Oops, I drew a point there. Let me erase the 1 point there. And there. Okay, so I just drew a diameter. Okay, good. Now what I want to do is I want to create a perpendicular bisector. I know we talk about this in the beginning of the school year. Perpendicular bisector means I'm going to cross it at 90 degrees and I'm going to go through the middle. So the way we do this for us to remember it, I'm going to grab my compass. I'm going to put it at the end there. Now, in this case, I know where the center is. The center of my segment, it goes through the center of the circle. It's about there, but I'm going to open my compass a little bit more. I'm going to go about there. So I'm going to open my compass more than half. And then I'm going to grab my pencil and I'm going to create an arc. Let me flip my compass a little because I'm going to move it now to the other side of the there. I'm not going to change the aperture of my compass. Instead, I'm going to grab my pencil and then drew an arc as well. I don't need my compass anymore. Now, let me zoom out a little so we can see exactly what I did. I'm going to grab a ruler. Let me flip my ruler here. I basically want to connect the two intersections of my arcs. You guys see the intersections that I made. So I'm going to go through here. Let me move my ruler a little better. There. Move my. So I want to point out, see the intersection here, I crossed it. There's the intersection here, I crossed it. Interesting though. Let me change this now to blue. so we can see it. I want to see, I created two diameters. Created two diameters. They cross each other at 90 degrees. So I'm going to say, well, this point right here, I see the point where my diameter crosses, touch the circle. This point right here, this point here, and this point here, those are going to be the vertices of my square. I know in the last section when we talk about parallelograms, one thing, because I'm drawing a square, right? A square is a parallelogram. One thing I said was that diagonals cut each other in half, and then well, isn't one diameter cut in half two radii? Okay, so my diagonals were cut in half. In this case, my diagonals are equal to each other because they're both diameters of the same circle. So my diagonals are equal. And remember how I said they are equal when it is a rectangle, but a square is a rectangle? So it's a parallelogram because they cut each other in half. They're equal, so it's a rectangle. That means parallelogram and rectangle combined. That's what we call squared. Now that I have my corners, I'm just gonna grab my ruler. Connect those two vertices there. I'm just gonna, oops, grab my ruler to the other side. Grab my marker. No one told me that my square had to be standing in a specific way. So my square is going to be a little tilted. That's fine. No one, it's not against the rules. Just trying to connect my two vertices. It's about there. Grab my ruler, bring it down. I know my two sides are parallel, so that's why I use the ruler without moving it. And that's it. If you measure the sides, the sides are going to be equal. If you measure the angles are going to be 90 degrees. I happen to have two. I happen to have a squared in the corners. The vertices of the corners are on the circle. So that's what we call a squared inscribed in the given circle. Pretty cool. Now 17 says construct a regular hexagon. Okay, so let me show you guys here. Let me construct here. Construct a regular hexagon inscribed in the given circle. So I'm gonna do 6 sides, and all 6 sides are on the circle. So let me show you guys how to do this. Let me zoom out a little. This circle is too big. Okay. First of all, let me just draw a point on the circle. Let me move to red. I'm just going to draw a point anywhere on the circle. So there. And that's going to be where I'm going to start. So let me put that there. Let me put my compass on the center of the circle. It seems like I got it there. And I'm going to do an arc such that I cross my circle twice. And then I'm going to move my point to here, to this intersection. And I'm going to move, oh, not there, not that. Okay, I'm going to move my pencil. I'm going to create an arc. Interesting. I want to show you something really cool. It touches the previous point. Nice. Okay, now let me move my compass here. Am I on the point? Yep. It's creating like a little flower. Am I on the corner? Yeah, it seems like I'm right there on the point. Pretty cool. It's creating like a little flower. We call that a daisy design. I can finish it. I can create my daisy design. I can create the petals here, but I don't need to complete the whole design. I see already. Let me do blue here. I already see I touched the circle at 6 points. Here is 1 point, 2, 3, 4. Like I said, we can complete the daisy design, but I'm not going to do it. You guys see my 6 points? And then all we got to do is just grab a ruler and connect my points. A friend of mine asked me one time, how accurate is this? I'm like, as accurate as your points, it's your measurement on your ruler. How are you on the points? Or are you a little bit off? You see, I feel that I am on the point there. Let me rotate my ruler here. Oops, not that, not there. The ruler is what I'm trying to move. Yep, seems like I'm there. Connect these points. I encourage you guys to try this at home. Just draw a circle and then connect these. You guys see a hexagon, right? 6 sides. You guys see my vertices are right on the circle. If you were to measure all the sides, you will find out they are the same length. If you were to measure all the angles on the inside, you will find out they're all the same. As a matter of fact, they'll be 60 degrees inside. And that's basically how we do these. Cool. So those are questions 16, 17. Again, I want you guys to know how to do these. We might I quiz you guys on these. Not me, but I'm looking at state testing, stuff like that. So make sure you know those. Now here, we're going to review a little. This is going to be a homework. We're going to review formulas that you guys have seen before. But these formulas we're going to be using a lot in the future. So I really need to have you guys remember these. We're going to practice on these again. Again, we're going to be using these a lot, especially the distance formula, questions 20 and 21. Question 18 and 19, I'm asking find the slope of the line through each pair of points. So given 2 points, I want you to give me the slope of the line. Okay, for us to remember, how do we get the slope of the line? Given 2 points, I'm gonna call this x1, y1, which means the x of the first point, the y of the first point, and then the other point I'm gonna call it x2, y2, which means the x of the second point, the y of the second point. That's what the x1, y1, x2, y2 mean. Now the formula for the slope, we call it m because the slope tells us how to move. The formula for the slope, if we remember these, it is y2 minus y1, basically the second y minus the first y, all over x2 minus x1, which basically means the second x minus the first x. Might give us a fraction, simplify your fraction, and then that should be it. So let's take a look for question number 18, and I'll even rewrite the formula so it sticks to my head. The slope is the second y minus the first y all over the second x minus the first x. So in our case, I'm going to have 8 minus 18. Because see, this is the second y. Here's the first y. So 8 minus 18 over 19 minus 7. The second x minus the first x. My case here, they were all positives. It was easy to deal with. Some cases you might deal with negative values, but that's not too hard. Remember, with negative values, when you have a minus a negative, when you have two negative signs, just change it to a plus sign. Now here, 8 minus 18. 8 minus 18 is negative 10. At the bottom, 19 minus 7. I know 19 minus 7 is 12. If you have a negative sign, just one negative sign, whether it's on the top or the bottom, bring it to the front. If you have one negative sign, whether the negative's on the top or the bottom, bring it to the front. So this is negative 10 over 12. Now, if you happen to have two negative signs, they cancel each other out. So it'll become positive. Okay? Then simplify your numbers. So divide them as much as you can to make your numbers smaller. But you have to divide the top and the bottom by the same thing. In this case, let me divide each by 2 because I see they're both even, so I can easily divide by 2. So it's going to be negative 5 over 6. Notice I divided each number by 2. So it's negative 5 over 6. Okay. If you can simplify your numbers even more, do simplify. Now, how we're going to type this? For the negative is just a negative. That's why I ask you to bring it to the front. So it's negative 5 over 6. The way we're going to do this is 5 backslash 6. So this is what I should be getting if this was my question. The slope is negative 5 over 6. Let's take a look at question number 19. Find the slope of this line. And for me to remember the formula, the second y minus the first y over the second x minus the first x. So in this case, I'm looking at the y values. Here's the first y and here's the second y. So I'm looking at 15 minus 2. For the x values, here's the first x and here's the second x. So I'm looking at 14 minus 0. Again, it was easy. They're all positive, so it's easy to write. Now, when I write, if there's two negative signs, make sure you change the two negative signs to plus sign. So people might be like, what do you mean with that, Mr. Donso? What if I had 15 minus a negative 4? What if I had something like that? Well, the two negative signs become a plus sign, so it's 15 plus 4. Right? That's basically what we're going to do. But here, okay, coming back to my question. 15 minus 2. Well, that's 13. At the bottom, 14 minus 0. Well, that's 14. I look at signs. If there is a negative sign, whether it's on the top or the bottom, bring it to the front. I have no negative signs. Then I look at my numbers. Can I divide them by something to make them smaller? Keep in mind, I have to divide the top and the bottom by the same thing. Can I divide them to make them smaller? No, not the case. So then that's the answer, 13 over 4. The way I'm going to write this is 13 backslash 14. All right, 13 over 14, that's what I meant. 13 over 14. Not too bad with the slope, but how about the distance formula? Now, this is something you guys might have seen before. The distance formula, let me remind you guys of the formula. You guys have seen it. If not, I'm going to use it here. I have the second y minus the first y all squared plus the second x minus the first x all squared. And all this is inside a square root. You guys might have seen this formula. You guys, I'm pretty sure your algebra teacher covered this. But here's the formula, so I'm gonna use it. So I'm gonna go, okay, the the y's. I'm subtracting my y's first here. So here's my first y, here's my second y. So I'm gonna go -2 minus a -5. Okay, and all this is gonna be squared plus. And then second x, so here's my first x, here's my second x. So I have the second x minus the first x. So I'm gonna go 5 minus 1 all squared, and this is inside a square root. Okay, so let's see. Let me worry about the parentheses first. The first parentheses, two negative signs become a plus sign. -2 plus 5, that's 3, right? So I'm gonna call this 3 squared plus 5 minus 1, because I'm looking at my parentheses, 5 minus 1. 5 minus 1 is 4, right? So I'm going to call this 4 squared, and all this is inside a square root. Okay. Now, type that in. Type on your calculator, the square root of 3 squared plus 4 squared. Now, some of you might be like, oh, how am I going to type that in? Well, good thing is that I gave you guys a good calculator on Canvas. Let me come back here to my Canvas. Here at the side, I see calculator. Let me click on it. And then it's gonna say that I'm gonna open in a new window. Okay, open it in a new tab. And there, so I'm literally gonna, from this square roots, because I'm doing square root, I'm gonna use this first one. And remember I said 3 squared plus 4 squared? So I'm really gonna go 3 squared plus 4 squared. And then I press enter. And it tells me it's 5. We could have figured, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, so the square root of 25. Yeah, but that's algebra level. We're geometry, so we can just type it in. The square root of 3 squared plus 4 squared, it says it's 5. Good. So let me come back to my work here, and my answer is going to be 5. That's not bad. Let's take a look at question number 21. Here's my first x, here's my first y, here's my second x, and here's my second y. And I remember the formula. The second y minus the first y all squared plus the second x minus the first x all squared. You might see a formula where the parentheses are swapped. Instead of here, I have I'm subtracting my first one, I'm subtracting the y's. On the second parenthesis, I'm subtracting the x's. So if you guys Google the formula, sometimes they switch the parentheses. First, they have you subtract the x's, and then they have you subtract the y's. Does it make a difference? Not really. So it doesn't matter which of the two parentheses comes first. Okay? Now let's take a look at here. So for the first parentheses, the second y minus the first y. So I have 8 minus a -6, an all square. Plus, on the second parentheses, the second x minus the first x. So 6 minus 4, all squared. And this is inside a square root. Okay. For the first parentheses, two negative signs, I know that becomes plus. And I know 8 plus 6 is 14. So I'm going to call this 14 squared plus 6 minus 4 is 2. So I'm going to call this 2 squared. And all this inside of parentheses. I mean, the square root. So I'm really going to type the square root of 14 squared plus 2 squared. Good thing I have my calculator now. I'm going to go here. I'm going to go square root 14 squared plus 2 squared. Entered. I see that I typed it in right. Okay, so now it gave me a long decimal. Whenever we have decimal, and even though the instructions doesn't say anything, like where to round up, we're always going to try to round it to 2 decimal places. So 2 decimal places, okay? Round it to 2 decimal places. So I see here 14.1421. Okay. Let me come back to my work here. I remembered if I go here at 14.142, right? That's what my calculator said. 14.1421. But even though I said 2 decimal places, notice I wrote 3. The reason why, because I look at my 3rd decimal place. It's too small. Yeah, too small means 4 or less. When they're too small, just ignore it. If it was not small, like 5 or more, remember it will push the previous number up. So the 4 will become a 5. In my case here, it is just going to be 14.14. Let's go for 2 decimal places. Now, if it says 1 decimal place, then obviously round it to 1 decimal place. Okay, that's not bad. There you go. That's basically what we did today.